In today's video, I will teach you how to create a professionally structured architecture for a React front-end application. We'll be going over the best design principles when it comes to folder structure, as well as including MobX and Axios inside of our application. Without further ado, let's just get into the tutorial. So then, let's first actually create our project. I've opened up a folder here inside of my code editor, and I will open up my console and start writing some commands. First, I will actually create my React application. We'll run npm create. We'll use Vite to actually create our React application. So do Vite at latest. We'll call this professional React app. We'll give it a template with React TS, as we'll be using TypeScript for this project. We'll select ESLint, yes, and let's let it create our project. Perfect. As you can see, we now have a new folder with all of our contents for our Vite application. Next, let's actually cd into our application and install the necessary packages. The first package I'm going to install is React Router DOM. This will let us actually create a router and manage routing inside of our application. Next, we'll install MobX. We'll install it with MobX and MobX React Lite. And finally, Axios as well. If I head over to our package.json, this should all be installed. And it looks right. Before we continue, you might be curious on what Axios and MobX actually do. So then let's start with what Axios actually is. Axios is responsible for talking to your backend server. Axios gives you a much nicer API and useful features such as base URLs, authentication headers, interceptors, automatic JSON parsing, request cancellation, and timeouts. It is a very standard package that is used within front-end applications to actually manage the connection between your front-end and your backend. MobX, on the other hand, has nothing to do with APIs. It's more for managing your project state. For example, imagine your application has a logged-in user, a shopping cart, notification system, theme, or loading state. Those values need to be shared across a lot of components. Instead of passing props through several multiple components, MobX stores all the data in one centralized store location. This is why it's extremely powerful and useful for large-scale applications. Hence why we'll be using it in today's video. I'll show you how to set both of these up and how to expand on them in the future. Without further ado, let's open up our source folder and actually get to creating some folders. The first folder we'll be creating is our API folder. This folder will be used to actually create connections to our backend database. The next one we want to create is our stores. This is going to be used for MobX, where we're actually going to be storing our data inside of our files. Next, we'll create a pages folder. Here we'll have pages for our front-end application. We'll also create a folder for our components. Here we'll store our React components, which our pages will be using to actually display the components. We'll also be creating another folder for types, which will store our models, as well as utils, for any utilities that we'll be needing. With that is all of our folders inside of our source directory for our project structure. First, let's actually get to creating our Axios connections. So inside of our API, I'll create a new file called axios.ts. Inside this file, we create our Axios application and also give it some endpoints. So we'll import Axios from our Axios. Then we'll export an API, which can be axios.create. We'll give it a base URL, which is going to be a base URL of our server that we're going to be contacting. Let's just give it some basic example on api.example.com. Of course, you would replace with your backend server URL. And next, we'll specify a timeout, which will be the amount of time before we time out with our connection. With that, we would create a basic Axios connection. Next, I'll show you the power of interceptors. I mentioned it earlier, but this is one powerful reason that Axios is getting used all the time. With most applications, we use a JWT token to actually create authentication between our frontend and our backend. Interceptors allow us to actually send requests which will automatically have things embedded into each request. For example, our JWT token. Instead of manually specifying it within every request, interceptors allow it to automatically use that token with every request. So let me show you a basic example. API.interceptors.request.use. We'll pass it a config, and inside of our function, we'll create a token, which will be from our local storage. We'll get the item of our token. We check if the token exists. Then all we do is inside of our config headers authorization, we attach our bearer token. And then we return our config. Think of it as some middleware that lets us embed our JWT token if it exists into each request. Now I'm not going to get too much into actually creating all these JWT tokens and everything like that. I just wanted to show you the power of interceptors within Axios. With that, let's actually get to creating some endpoints. I'll create a new file here called user.api.ts. Inside of here, we'll import our API that we've created in the Axios.ts file. So from /Axios, and we'll create an object that will store all of our requests. So export const user API is going to be equal to an object where we have some sort of functions. For example, get user, as well as maybe like create user. Again, this can extend for however many you want. This is just a centralized object where you have all of your requests to call for your database. Now, to actually call our database, inside of our API, we've already set our base URL. So what we actually specify in the following code will be whatever will be appended to that base URL. So in our get users, let's say I want to return api.get, which is we're going to be calling a get request on /users. So what this will mean is that we'll be calling https, what do I call it here again? api.example.com/users. That's what our request will look like. Let's say we want to create a user. We'll be using something known as a post request. Let's do that. We could do api.post/users, and we can specify a second argument. For example, our name. Of course, we actually need to get our name, which is where we can actually pass parameters into these functions. So I'll just do a name string. So this will send a post request to /users with our given name. Of course, you can feel free to add objects or anything here. But speaking of objects, if you noticed, we created a types folder. Here we'll actually specify our models for our application. So if we head on over to our types, we can actually specify types and models of the structure of the data for our application. So as we're using TypeScript, we're actually allowed to automatically convert our request response from, for example, a GET request into whatever we want. So let me create a type for user.ts, where we'll just export an interface for our user, say give an ID of string and a name of string. We're actually able here, inside of a generic, specify we want to get our user from our user types and a user array. What this will do is that Axios will actually return and cast our data into our specified interface. So now we're actually able to call functions with our type safety. Very cool and very useful. Of course, here you're able to go as far as you want. You can create as many functions as you need to support your backend server, as well as passing whatever data you want through parameters here. As this actual object doesn't class as an Axios or anything to do with Axios. The only thing that Axios is from our API where we actually call the specific methods. So that's why here I was able to pass in a name of string. Anyway, it's pretty safe to say that this is how we can utilize Axios within an application. The next thing I want to go over is our MobX. So inside of our MobX, we'll create a couple files. Inside of our store, we'll create a store context.ts file. We'll also create a common store.ts file. And we'll also create our user store.ts file. Let's actually get to work on our user store first. As you remember, MobX is think of it as a way to access state. It's a store. It stores some sort of data. So we can actually use that to our advantage. So with our user store, of course, we have our Axios requests, which actually call the database. But we actually want to store that data. Think of it as like a mini cache. This is what we're going to be doing here. So I'll create a new class called user store, which will have a property of users, which will be a user from our types array, set to an array. We'll also have a loading set to false. Set equal to false, and also an error property, which will be equal to null. Now we're going to start utilizing MobX inside of our class. We'll create a constructor. And inside this constructor, we'll call the function make auto observable from MobX when we pass in this class. What this does is it marks all properties as observables. Pretty much saying MobX now attaches a sort of tracker on each one of the properties that we specified up here. Because the way MobX works is inside of a React component, when we specify the React component to utilize MobX, and if our React component utilizes a store that tracks a specific property, when that property changes, it will re-render the component with the new data. So what make auto observable does in our constructor pretty much says, hey, MobX, track all of our properties. Of course, you're also able to manually specify these, but if you pass it like this, you don't need to explicitly specify what you want. With that, let's actually get to creating a sort of store method. For example, async fetch users. Here, first we'll set the loading to true. Next, we can actually get the response from our Axios request by saying await user API dot get users. And if you hover over a response, you can see it's an Axios response of user array. Then what we're able to do is we're able to say this users is equal to response dot data, which gives us the data from our Axios response. And finally, we can set loading to false. And that's how easy it is. What we've been able to do here is we've been able to create a sort of state manager where we actually call our database and store our data in sort of a state cache. Now, there is a bit of an issue with this code. It looks fine, but the issue is with asynchronous code and MobX. When we actually start using async and await inside of MobX, we kind of lose our guarantee of state reloading. So we actually need to call another function from MobX called run in action, which pretty much takes in a callback function that will run and update the state of our class. This must be used when we're using async await to guarantee that the state will actually update and our component will render. Also, you might have noticed error handling hasn't really been managed here. So let's actually update this function to utilize these functionalities. So a nice way of doing this is actually using a try catch, where we catch any error and we'll put all of this code in here actually. All we really need to do is do this. And anything after the first await call needs to be put in a run in action. So we'll do a run in action, passing our function, and we'll set this users to response data, but we'll also set loading to false. Inside of our catch, we'll do another run in action because we're going to be modifying the state of our error. We'll set this dot error is equal to error, and this dot loading is equal to false. And just like that, now we've got professional error handling within our MobX store and a guarantee that all the data will actually get stored and that the components will re-render. And this is really it, to be honest, with our user store. Every time we want to actually call a backend function, say create user or anything like that, we'd like to do that probably through our user store. Here, we actually fetch our users, But we also have our create user function, which will look very similar, where we, again, set our loading. In a try catch block, we actually call our function, our user API, which we called create user. We wait for a response, and then we do specific updates, such as updating our users over here, our user store. Anyways, with that, that's the basics of how a user store works. Of course, feel free to experiment and try with any kind of store. We're just using users as an example. Next, let's actually go over to our common store. In here, this is going to be the main repository for all of our stores. Because what a very good practice is to just put our stores inside of a React hook. So we need a centralized we need a centralized object to actually store all of our stores. Of course, because at the moment we've only got one store, but eventually we're going to have multiple stores for the multiple different things inside of our application. Therefore, we need a common store that brings it all together. So inside of our common store, I'll export a class called common store, which will just contain a user store, which is equal to a new user store. And then we can export our common store, which is a new common store. And that's really it. The more stores you've got, just put them in here. Finally, we actually need to create a React hook to actually store it inside of our context. So we'll do it inside of our store context file. We'll create a store context, which is equal to create context, where we pass in our common store. And finally, we'll export our store as a hook. So use store, which will be equal to a function where we pass use context, and our context will be our store context. Now, as you can see here, we're getting an error that we're missing some sort of properties. This is because I've actually included create context from React root to DOM. This should be coming from React create context. As you can see, all our errors go away. So now what we've done is we've actually created a context, and we've created a use context hook with our new store context, which is pretty much a link to our common store, where we can access each one of our stores that we've created inside of our store. Now then, let's actually just create a page. So new file, we'll create a users.tsx, for example. We'll create a component. We'll say export const users, which is going to be equal to a function. And inside this function, we could just render a React component, return here, and we'll actually utilize our newly created stores. So to get our store, we can actually create a store variable from our hook use store. And now to actually access our user store, we can do store.userStore. And if we were to have more, they would show up here. With that, you can also just destructure this. So we'll actually just do user store like that. And we'll get our user store as a variable within itself. We actually need a way to call the data because we're just currently accessing a store, but we're never actually calling the functions such as fetch users, which actually loads our users into our state. So to do so, we'll use an effect, use effect from React, where we'll pass in our user store dot fetch users, and we'll give it an empty parameter list. Now we get an underline here saying that we're missing a dependency, and there's nothing wrong with actually passing it in. So let's do that. And just like that, we have now created a way to actually get our users. As you can see, we are not returning anything. We're not storing it inside of our component or anything like that. That's because all of our state is managed inside of this store. See, we load our response, our data into our users. Because now, say we've got multiple pages that access the same store, we don't need to set multiple states for it. It will all be stored in there. Now, as you notice probably from our user store, we have two properties, an error and also a loading. This is where we can actually check if we've got an error or if we're still loading to render some sort of loading component. We could check if user store.loading, and we can actually return some sort of div that has a p tag, maybe, that says loading. We can also do something if user store dot error. We can return, or we could just console dot error, the error. Oh, user store dot error. Again, feel free to manage this logic however you want. I'm just giving you an example of what we can actually accomplish. Anyways, with that, let's say we want to list all of our users. We can easily do that by doing user store dot users dot map, as we are using an array. We can map over our users. We can create a p tag, give a key of our user.id. As you can see, we actually get our IntelliSense here because our user is actually of type user from our type over here. So we'll give it a key, and now we can actually just give it a user.name as the value. And just like that, we've connected everything together. Now there are a couple extra things we could do. For example, in every component, we would have to call fetch users to ensure that the users are actually there. But this means this will have to get called every single time. One way to omit this is to just check if they are loaded. So we create a new property here, loaded, which will be set to false. And we can just check if loaded, this dot loaded, and we can just return the function. Pretty much stopping the execution of everything here. Because if we go back to our pages, every time our component re-renders, we're going to have to call this. And that just seems like a bit of a waste. So one way to omit this is to just do an early return, where we check if loaded is true. Of course, that means here we need to set this dot loaded to true as well. So after our data loads, we can set it as true. Now, there's one thing I missed, and that is at the moment, nothing will happen because we're not letting MobX observe this component. What this means is we're missing one key function, which is the observer function from MobX. So we need to actually mark this here, observer, in brackets like this. And what this will ensure is that MobX now has access to observe this component, which means we're able to link our store to this component, allowing it to be re-rendered when something in our store changes. If anything changes, we've got another user, loading, loaded, error. Any one of these states change, our component will be re-rendered. If you miss observer, you'll notice that nothing will really happen. While I'm here, let's actually reset the error. Because here, let's say we actually do get an error, but we then re-render and we don't get an error. Our error will still be true, meaning we'll be stuck in our error state here. So inside of here, we'll also set this.error to null. And just like that, that should be all good to go. Now the one final thing that's left is routing. We installed React Router DOM. Let's actually utilize it now. So I forgot to create a folder here, but we'll create a router folder. Inside of here, we'll create a new file, which will be called router.tsx. Inside of this router, we'll actually utilize React Router DOM to route to our pages. All of our pages, again, live inside of our page directory, so we can use that. First, I'll actually export a new router, which will be from create browser router from a React Router DOM. Inside of here, it'll be an array with objects, which will specify our directories. For example, the first property will be path here. Our element will be our app component. Then for children, we can specify some properties, such as index will be true. An element will be, let's say, a home page, which currently we don't have, but we could add that straight into our pages here. Create a new file called home.tsx. Then we can have another path, say path of users, which our element will be our users page that we created just now. We can also specify a not found. Outside of here, I can add a new object with a path of an asterisk, meaning everything else, with the element of, say, like a not found page, which again could exist inside of our pages here. Create a not found.tsx. With that, you structure the way your application's routing works. Of course, we need to actually implement this. Back inside of our app.tsx, let's actually get rid of everything here, as we don't really need this. Let me actually include our outlet. Outlet comes from React Router DOM. And then finally, for us to actually be able to use our routing, if I go back to main.tsx, we need to actually change all of this. Inside of here, we can specify our router provider, which will specify our router as our router. Now our routes should work. But we're missing one more thing. We need to actually add a store provider, which is something I forgot to do. If I go back to our store context, in here, we need to export a new variable called store provider, which is going to be equal to a store context.provider. With that back inside of main.tsx, we can actually surround this with our store provider, which has the value of our common store. And just like that, now we should have a fully working front-end application that manages API calls to our database, has a MobX store where we can store data and call our database. We have a structure for our pages, components, and a basic router. With that, I think that's pretty much everything else. Feel free to nest as many folders you want or mess around with it. This is just a template structure. I mainly wanted to go over in this video how to utilize MobX and Axios within a React application. So feel free to experiment, expand on this project, and do whatever you want. I hope you were able to learn something from this video. If you want to get access to this code, it will be down in the description inside of my GitHub page. As I mentioned earlier, please feel free to mess around with it, make it yours. It's your project, it's your responsibility to make it however you want. But this is just a rough outline of how my project looked like underneath when I use Axios and MobX. With that, thanks for watching, and I'll see you in the next one.